In this problem, we are finding out all angstrom numbers ranging between 1 to 1000. Question is coming in the mind that what is an angstrom number? An angstrom number is that number whose sum of all digits of that number, each to the power of number of digits of that number, is equal to the number itself. If the definition is not clear to us, let us go for one example. So 371 is an angstrom number. Why? 371 is having 3 digits. So sum of all digits, each to the power of number of digit to the number. So 3 to the power of 3 plus 7 to the power of 3, that is 7 cube, plus 1 to the power of 3, that is 1 cube. If you go on adding, you are reaching to 371. So 371 is an example of angstrom number. We are supposed to find out all angstrom numbers between 1 to 1000. So now how to do it? Let us suppose here we have used that very program which we discussed earlier to calculate the sum of digits of a given number. So that in that program we have shown you that how to calculate the number of digit in a number. So here we shall be taking the help of function log. So log of 10,000 or to the base 10 or log of 1000 to the base 10, the values will be 4 and 3 respectively. So log of 1000 to the base 10, the value will be 3 because 10 cube is equal to 1000. Log of 10,000 to the base 10 will be equal to 4 because 10 to the power of 4 is equal to 10,000. So all the values which are equal to or greater than 1000 and lesser than 10,000 will have the value 3 or 3 point something. So if you take the integer part of that, so I shall be remaining with 3, and if we add 1 with that, then that will become 4. 4 means 4 digits are there in the respective number. So here also, here how many digits are there? We are having 1, 2, 3, 4, 5 digits. Log of 10 to the base 10,000 will be 4, and 4 plus 1, that will be 5. So the very simple formula here is that log of n to the base 10, take the integer part of that and then plus 1 will give you the number of digit to the number, because this number of digit will be going to the exponent part for each and every digit. So I shall be doing one for loop for I is equal to 1 to nd, and then I shall pick up each and every ith digit from the number, and the digit will be added with the sum after putting d to the power of nd by using this particular formula, and then sum will get calculated. Let us consider 371. So here nd will be 3 because it is having 3 digits. Okay, so I will be ranging from 1 to 3. Initially when the value of I is equal to 1, then 10 to the power of 1 minus 1, that is 10 to the power of 0 is equal to 1. So 371 by 1 is equal to 371. Integer of that 371 mod of 10, I shall be getting 1 here. So 1 to the power of 3 will be added with the sum. Next time the value of I will become 2. In that case 2 minus 1 is equal to 1. 10 to the power of 1 means 10. So n by 10 will be equal to 37.1. So if you take the integer part, I shall be remaining with 37. 37 mod 10, I shall be remaining with 7, and then accordingly 7 to the power of 3, I shall be getting the value to be added with the sum. Last, when the value of I will be 3, then 3 minus 1 is equal to 2. So 10 square is equal to 100. So n by 100 will become 3.71. Taking the integer part, I shall be remaining with 3. Mod of 10 will give you 3, and then the 3 to the power of 3 will be added up with the sum. So in this way, picking up the ith digit from the number without changing the number itself can be done using this formula. So then sum is equal to sum plus int of pow d nd. So in this way I am going for d to the power of nd calculation. This pow is having the prototype declaration under the header file math.h, so that has to be included there. And if this sum is equal to n, then this is 1 angstrom number. So let me execute my program for the better understanding. So if I execute, you see all the single digit numbers will be the angstrom number, because 7 to the power of 1 is equal to 7. 7 is having a single digit, so 7 to the power of 1 will be equal to 7. 9 to the power of 1 will be equal to 9. And then 153, 370, 371 and 407 are the angstrom numbers ranging from 1 to 1000. In this way, the program can get executed and can give us our desired results. I think you are getting this logic, and for the better understanding of this particular expression and this particular expression, please watch the previous videos on the sum of digits of a given number, so you'll be getting better clarification on this issue. Please share your comments, please share your views on this tutorial, and thanks for watching this.